morning all of you. Today I will discuss a topic, medium access control sublayer, which is a part of data link layer. In my previous lecture I have discussed a logical link control, which is another sublayer of data link layer. Because I have already discussed that data link layer is divided into two sublayer, LLC and MAC. So the major functionality of LLC is the framing, flow control and error control, and the major functionality of this medium access control layer is the channel allocation. So what is the functionality of medium access sublayer? So the medium access sublayer, it deals with the broadcasting of network and their protocols. So it basically deals with the broadcast the network, and the key issue is how to determine who get to use the channel. So the major problem occur that we can't identify that who will use that channel and how we can allocate the channel to the source and destination. So it also called a multi-access channel or a random access channel. The protocols determine who goes next on the multicast channel. So with the help of this medium access control sublayer, we can easily identify that who will send the data into the channel. So that's why there will be no collision occur in the channel. It is a bottom part of the data link layer. LLC is the upper part of the data link layer, and MAC is the bottom part of the medium access sublayer. Now the channel allocation problem, we have to solve this channel allocation problem through the MAC layer. So the first is that how to allocate. The first major concern is about the allocation of channel, or how many users will use that channel. So how to allocate a single broadcast channel among competitive users. So for solving this problem, we can allocate the channel into two main part. First is a static channel allocation and second one is a dynamic channel allocation. So a static channel allocation means we have predefined, previously we allocate the channel to the through which the number of source can transmit the data. In the static channel allocation, we have used two type of multiplexing. One is a frequency division multiplexing and second one is a time division multiplexing. And it is when we have to apply this static channel allocation, we have only applied the static channel allocation method when we have a limited or a fixed number of users. So if we have a fixed number of users, only we can assign a static channel allocation, because if any user can move from the network, if any user can add or delete from the network, so in that case static method will not be used. So the disadvantage of this static channel allocation is when the number of users is large and continuously varying, or the traffic is bursty. So in that case we will not apply the static channel allocation, because as the number of users will increase, then there is a need of more bandwidth. So and we have a just fixed amount of bandwidth, so we cannot send a large amount of data. In that case the data will be lost. So in the static channel allocation, we have just a fixed number of users, and we cannot add or delete the users in the network. So FDM, it presents some problems. Now to avoid this problem, we will use another method of channel allocation, that is dynamic channel allocation. So dynamic channel allocation is a method in which the channel is to be allocated, or the bandwidth is to be allocated frequently, randomly, as the number of nodes will coming out into the network or it will go from the network. So these are key assumptions of this dynamic channel allocation. Station model, the model consists of n independent stations. Suppose we have a n independent stations and each with a program or a user that generate frame for the transmission. Suppose I just want to send the frame. So, the probability of sending the frame, generate the frame in an interval of the length of delta t is lambda delta t, where lambda is the constant value and the arrival rate of the new frames. So, once a frame has been generated, then station is blocked and does nothing until the frame has been successfully transmitted. Second is it is a single channel assumption. So, single channel assumption means a single channel is available for all the nodes, means there is a single channel, all the nodes are to be sent the data through this single channel. All the stations can transmit or receive the data through the single channel only. As far as the hardware is concerned, all the stations are equivalent, although some protocol software may assign priorities of them. The third key assumption is that a collision assumption. This is also a major concern in the dynamic channel allocation. What is this? If two frames are transmitted simultaneously and suppose if they are overlapped in a time, so the result is signal is garbled. This event is called collision. So, if we have a single channel and the two or more than two frames will be routed through this a single channel. So, at a point of time, both the channels will both the frames will overlap and your data will be lost. So, for that reason, there is a need of some collision detection. So, all these stations can detect the collision. For that purpose, we will use a carrier sense multiple access collision detection method. So, a collision frame must be transmitted again later. So, in that case, we will retransmit that collide frame again. There are no error or those generated by the collision. Now, the next key assumption is continuation of time. So, in the continuation of time, frame transmission can begin at any instant. We can start the transmission of frame at any instant of time. There is no master clock dividing the time into a discrete interval, means at any point of time, n number of users can send the data. So, there may be also a condition of collision. So, if all the nodes will send the data at the same time, so the data will be lost. So, for avoiding this condition, we will use a second method, that is a slotted time. So, in this slotted time, the time is divided into the discrete interval, or we can call it slot. We called it slot. So, frame transmission always begins at the start of a slot. A slot may contain 0, 1 or more frames. So, means in a single slot we can send more than one frame simultaneously. So, corresponding to an ideal slot, a successful transmission or a collision respectively. So, if we are sending the frames in a distinct slot or a specific slot, so in that case we can avoid the condition of collision. This is also a major concern which we have, which we will concern when we have to transmit the data frames. Next is about the carrier sense or no carrier sense. So, in the carrier sense, the station will sense the channel before trying to send the data. It will sense that there is some data in the channel or not. So, in the carrier sense, the station can tell if the channel is in use before trying to use it. If channel is sensed, if the station sends the channel, so if at that time if channel is busy, so the no station can send the data at that moment, because if there is already some data in the channel and without sensing the channel, if the sender will send the data, then there may be a condition of collision. So no station will attempt to use it until it goes ideal. So all these stations will wait until the channel will be in the ideal stage. Second, next is no carrier sense. In the no carrier sense, station cannot sense the channel. Sorry. In this, station cannot sense the channel before trying to use it. Means all the stations will send the data before sensing the channel. So they just go ahead and transit only later can determine whatever or not transmission was successful. So in this second case, no stations worry about the channel. Sorry. In this method, all these stations were sent the data without knowing that channel is busy or not. So these are various protocols, various multiple access protocols. Basically, these are divided into three categories. One is the random access protocols, second control access protocols, and third one is a channelization protocol. So the first category is a random access protocol. There are four type of random access protocols: Aloha, CSMA, that is a carrier sense multiple access, then carrier sense multiple access with collision detection, then carrier sense multiple access with the collision authentication. In the control access protocols, we have used three methods: reservation, polling and token passing method. Now, in the third method, that is a channelization of protocols. In this method, we will use three methods: FDMA, frequency division multiplexing, time division multiplexing and code division multiplexing access. So, first of all, we have discussed about the random access protocols. So, in random access protocols, these are also called a contention method, contention protocols method. In this, no station is superior to another station and none is assigned to control over the others. Means we can say that all these stations are equally responsible. No station permit or does not permit another station to send, means all are equally responsible for sending or receiving the data without the permission of others. At each instance, a station that has data to send, it use a procedure defined by the protocol. So what decision we want to make? So in this, there are four categories: Aloha, CSMA, CSMA with CD and CSMA with CA. So if we are talking about the Aloha, this is also called pure Aloha. In the pure Aloha, nodes transmit on a common channel. Means a single common channel is to be shared by the all stations. And transmit frame, in this method, in the pure Aloha, all these stations will send a fixed length of frame. When two transmissions overlap, so there will be a collision. Why there is a collision? Because no one can check. Every station is responsible for sending a data without knowing the channel, that it is in ideal stage or not. If feedback property is there, if the frame get destroyed, so the sender waits a random amount of time. Means after sending the frame, sender will wait a random amount of time, and after that it will resend that frame again. And it will continue send this frame until all the transmissions, all the frames are to be successfully transmitted to the destination. So, this is the concept of pure Aloha. We have these are 4 stations, station 1, 2, 3 and 4. All these stations send the data. Suppose station 1 send frame 1, 1, 2, 2, then 2, 2, 1, 2, 2, then 3, then 4, 4. All these stations simultaneously send the data to the from the channel. So, this is the algorithm for pure Aloha. We have to calculate the efficiency of the pure Aloha with the following method. K is a number of attempts, TP is a propagation time, average time, TR, TV is a back off time. So, we have just start, station has a frame to send. Initially, the value of K is equal to 0. Send the frame and it will wait a time, and the time is 2 into TP. If it will receive the acknowledgement within this time frame, then success. Otherwise, if it is not received, then K is equal to K plus 1. If K max is K is greater than K max and the maximum number of attempts is up to 15. So, again it will check, again the waiting time will check, and this process will be iterated again and again. This is one example of pure Aloha. Pure Aloha transmit 200 bits frame in a shared channel of 200 kbps. That is then to the valuable time is 2 into 1. It is 2 ms, and this means no station should send later than 1 Mbps before. So, we can easily calculate the throughput of the pure Aloha. So, the throughput for the pure Aloha is S is equal to G into e to the power minus 2G. The maximum throughput is equal to 0.184 when G is equal to 1 by 2. So, we can calculate the throughput of the pure Aloha with the following formula. So, in the pure Aloha, we can calculate this. The first condition is if we want to send 1000 frames per second, second if we want to send 500 frames per second, and in third condition if we want to send 250 frames per second. So, we can easily calculate the throughput of the pure Aloha. These are the examples. This is a slotted Aloha. This is another category. This is slotted Aloha. In this slotted Aloha, we have to divide the frame slot fix. We have to fix the slots for the particular frame or number of frames. So, here n number of stations, suppose there are 4 number of stations and each want to send the data. This is a collision duration. This is a slot 1, slot 2. These are the slots, and at every slot we have sent the frame. So, we can minimize the problem of collision in the network. If we calculate the throughput of slotted Aloha, it is S is equal to G into e to the power minus G. The maximum throughput S max is equal to 0.368 in the case of slotted Aloha when G is equal to 1. This is the process that how we can calculate this collision. This is another example of slotted Aloha. Same previous examples as we have taken in the pure Aloha, same example is to be taken here, but we have to calculate it with the help of slotted Aloha method. Now, the next is the carrier sense multiple access protocol. Carrier sense multiple access protocols, in that case we have all the stations first sense the channel before sending the data. So, protocols in which station listen for the carrier or the transmission and then accordingly are called carrier sense protocols. So, before sending the data, it will sense the channel. If channel is busy, so the data will not send by the source. So, there are two category of carrier sense multiple access protocol. One is a I persistence, N persistence and P persistence. These are the category of carrier sense multiple access protocol. In the I persistence, the station transmit with the probability of 1. This is 1 persistence. Non-persistence means the transmission. If channel is an ideal, if the channel is busy, it was a random time and tries to again. In the P persistence, the station transmit with the probability of P. So, if we have to compare it with the 1 persistence, so in 1 persistent, the station transmit with the probability of 1. While in the case of P, the station will transmit the frame with a probability of P. These are the example of 1 persistence, non-persistent and P persistent carrier sense multiple access. These are 3 methods of CSMA. Now, this is CSMA with CD. So, in CSMA with CD is a carrier sense multiple access with the collision detection. So, what happened in this method? In this method, a transmission as soon as they detect the collision. Suppose if collision occur in the channel, so it will detect the collision and quickly and if the collision quickly damages the frame, it saves the times and bandwidth. After a station detect a collision, it avoid the transmission at the moment with the random period of time and then tries to again to send the data. That no other station has started to transmitting in the meantime. If there will be a collision, so no station will send the data at that moment. This is example of collision of the with the help of CSMA with CD. This is a point of time where collision occur. A's collision detect and abort. First bit of A, first bit of C collision detection and abortion. Then this is a time. So, in this meantime, no station will send the data. This is CSMA with CD. This is an example on that. CSMA with CD. This is an algorithm and we have to calculate the throughput of CSMA with CD with this flow chart. Start K is equal to 0. Apply for the 1 persistence, P persistence on N persistence. Transmit and receive. If collision occur detected, then send a jamming signal and increment of K with 1. If no collision detected, it means the frame is to be sent successfully. This is a CSMA with CD. Now, the next is CSMA with CA, that is carrier sense multiple access with collision access. Collision authentication. So, in IFS, it can be used to define the priority of a station of a frame. In CSMA with CA, if the station find the channel is busy, suppose if I am sending the data and I have to check that channel is busy or free. Suppose if channel is busy, so it does not restart the timer of the contention window. It stops the timer and restart it when the channel becomes ideal. So, this is the process of IFS. Suppose it sends the channel, it is busy at that moment. then it will wait and it will not start the timer. When it found that channel is free now, then the timer will start. This is your contention window and it will send the frames through this channel. This is CSMA with CA. This is an algorithm of CSMA with CA. Start k is equal to 0. If channel is ideal, yes, then wait for IFS time. Here, still ideal, then it choose a random number R, wait for a slot, send the frame, wait timeout. If acknowledgement is received, then successful. If not, then again k is equal to k plus 1 and repeat this process again. This is the process of CSMA with CA. Now, the second method is controlled access. In the controlled access, the station consult one another. As I have seen in the previous method, no station can consult with another. Each and every node can send the data without knowing or without the consultation of another stations. But in this case, all these stations will consult with each other before sending the data. So, the stations consult with another to find which station has right to send. A station cannot send unless it has authorized by another station. So, we have discussed three methods in this controlled access: reservation, polling and token passing. This is the reservation method. In this, data station 1, 2, 3, 4, they have contact with each other before sending the data. This is a polling method. Sender A, machine will send the select to B. If it will get the acknowledgement from the device B, then it will send the data and get the acknowledgement. This is the method that how we can pass the token. This is a token passes method. The machine which is ideal and who want to send the data, first of all it will sense the channel. If channel is ideal in that stage, then it will generate the token and it will pass the token into the ring. And at the time the station which is pass the token, he is only responsible for sending the data. Next method is the channelization. In the channelization, it is a method in which the available bandwidth of a link is shared. In this method, we have to share the bandwidth. So, three methods are there under this category: FDMA, TDMA and CDMA. It is a multiple access method in which the available bandwidth of link is shared in time, frequency and code between different stations. So, in FDMA, available bandwidth of the common channel is divided into the band or separated by the band. This is the process that how we can create the bands. In the TDMA, the bandwidth is just the channel that time shared. In this method, instead of sharing the band, we have to share the time between different stations. This is a TDMA method. The time slot is to be shared by the stations. In the third method, CDMA, one channel carries all the data, all the transmission simultaneously. At a time, only one channel will share all the data in the CDMA. So, this is all about of medium access control sublayer. Thank you very much.